Okay. Good evening, how's it going, guys? How's it going? This is a little follow-on from a previous video I did on a Banda Viking 7K, and this now is Banda Viking 10K. It should do about 14,000 or 13 or 14,000 watts RMS at 14.4 volts. This is less of a bit of work. This is less work. This is more my own kind of curiosity. This is more my own curiosity. I want to know whether these amps come with bad FETS from the factory or not. So as you can see on the bench here, we have Banda Viking 10K. This is a big amplifier. It's a bit of a shitty build actually, isn't it? You can see the two different heat sinks that have just been butted and welded together or whatever. And obviously you can see all the colour there has changed where the two cases are butted together. It's not so bad. It's just not the nicest of looking things. But yeah, so what I'm going to do is I'm going to show you, I'm going to let you see my methods for testing the FETS which are in this amplifier and seeing how well matched they are. Because I don't believe the FETS that Banda have put in this thing are proper FETS. I don't believe these are legitimate, decent FETS that are going to last. I got a feeling these are going to die. So I wanted to show you my testing methods to find out how to see what the jam is. So we're going to turn her over like so. We're going to crack the back off this baby. Now this amplifier I'm kind of planning to use in my own build. So I'd quite like it to be, you know, prim and proper. I'd quite like it to be tip-top condition, working well. I'm not gonna die, so should be a pretty interesting video. Okay, so as you can see, this amplifier does, for a Brazilian, have some fairly beefy looking internals. Not bad at all. Not bad at all. The output section is over here. This section here. Let's see if I can. There we go. That's a bit better. There we go. So yeah, the output section is here. These are the 16 output FETs. We've got 8 on one side and 8 on the other side. And this amplifier is using 90N20D MOSFETs. So it's using the same FETs that the Banda Viking 7K uses, but it's just using twice the number of them. So these are 90N20. That's 90 amp. Wait, that's 90 amp and 200 volt. 90 amp, 200 volt FETs. Holy shit, that's actually pretty crazy. Yeah, damn. That's that's pretty crazy. Now, I want to show you the reason why I believe that this amplifier might have pretty bad FETS from the factory. And to do that, I'm going to take my little handheld camera here and we're going to zoom in on the amplifier like so. So, I've undone four of these FETs. So we're going to take away the clamps, the heatsink clamps here. We're going to have a look at the FETs that this amplifier is using and what batches they are. Just going to get a little bit of thermal paste and rub that on the logos here so we can see the codes a bit easier. That's a little trick I learned. The thermal paste gets kind of stuck in the lettering and makes it easier to read. Also just going to clean off my camera lens here, that's a little bit dirty. Okay, I think that's a bit better. Right. So wait for this to focus. I'm just going to try and get a camera angle that allows you to see this well. Okay, so the first FET that we have here, as you can see, 90N20D. This is batch 305P-W9. The one next to it is batch 305P-W8. However, although these two FETs are supposedly from the same factory run, just very slight different batch numbers, this one was after the other. So W8 and W9 are just after one another in batch production. Despite being made supposedly in the same factory around the same sort of time, the actual inscription, the laser cut inscription, is completely different. This is one kind of font that you can see. It's like sort of more rounded. This is a very stretched out font. It's a different color. It's much more blurry. It's different position than this one. So I've never ever seen this before. FETs that come from the same factory that are just one batch apart, for example, are identical in the way that the logos here are printed. So this makes me question what's actually going on here. What are these FETs? Where do they come from? Why is the printing different, so different on these two, even though the batch numbers are pretty much the same? Let's have a look at the two next to it. So the two next to it are identical to, oh no, hang on, we've got W9, yeah. So the two next to it are identical to the first one here. So we've got, this one is one type, then we've got type 2, type 1, type 1. Let's see if we can read some of these. So we've got type 2 here, type 1, type, is that W8, that one? W9, and then this last one is W9. So we've got a whole selection, a whole different mix mash of W8 batch and W9 batch parts on this side of the amplifier. So I'm interested in finding out how well these FETs work with each other, and you know, basically the idea is, with having all these FETs in parallel, the idea is that they all share the load equally. So these FETs are the things that do the amplifier's power. They're the things that take the rail voltage and they turn it, well, they turn it into an audio signal with Class D switching frequency. So all 16 of these FETs need to share the load equally in order for the amplifier to be reliable. If they're not sharing the load equally, then some of these FETs are going to get hot quicker than the others, and they're going to be taking the brunt of the load. Therefore, they are likely to blow and cause the amplifier to fail. So, the purpose of this test, what I'm doing is, the reason I'm unscrewing all of these MOSFET clamps is I'm actually going to take the clamps off like so. I'm going to bend the FETs away from the heatsink so that they are not clamped to the heatsink at all, so that they get hot nice and quickly. I am then going to run a test tone through the amplifier, and I'm going to have it attached to my dummy loads over here. I've got 3 of them wired in series, which gives me a 12 ohm load. So nice and high. I don't want to put too much pressure on these FETs. I don't want to draw too much current through them when they're not clamped to the heatsink, because this is very dangerous. The test that I'm doing here is very dangerous because you can very easily kill your FETs in the amplifier by not having them attached to the heatsink and driving a load. So I do not recommend doing this unless you know exactly what you're doing and you have absolute control over the amplitude and the resistance of your load, and you're able to monitor the temperature of all the FETs at the same time, which I'm able to do with my thermal imaging camera here. So yeah, we're going to pull the FETs away from the heatsink, and I'm going to drive a load, a 12 ohm load with about 45 Hertz, and I'm going to look at my thermal imaging camera and see, I'm looking for all the FETs to be heating up equally. I want them to be within like 3 or 5 degrees, you know, there's always going to be a little bit of deviance, but I would like them to be within 3 degrees Celsius of each other. So obviously they'll start off at room temperature. I'll probably run them up till they get to about 40 or 50 degrees. And I am looking for all these FETs to all be between plus and minus 3 degrees of each other. Or no, sorry, plus and minus 1.5 degrees of each other. And that will then tell me that they are sharing the load equally. If they're not sharing the load equally, if some of these FETs are actually bad and they have a much higher RDS than the others, then what will happen is that the FETs with the lower RDS will take the brunt of the power and they will get hot. And the FETs with the higher RDS, the current won't favour the path of the FETs with the higher RDS, and therefore they won't get hot. So this is a pretty interesting little test that will show us whether these FETs are all well balanced or not. So here I'm just pulling the FETs away from the heatsink so that they're not passing their heat through to the case. Okay. And I'm doing this test. I'm not going to be using my Dell server power supplies because there's too much current available. I'm going to be using my my current limited supply here, so I can set a current limit and I can monitor the current drawn from the amplifier at all times. So that's another safety measure that we've made for this test. Okay. So I have the power supply here. Let's turn her on. I'm going to allow, I don't know, let's say about 10.8 volts to pass. And because I want this amplifier to turn on quickly, I'm going to allow the maximum amount of current to pass, 20 amps. This amplifier does demand quite a significant bit of current in order to charge the rail caps. We've got a lot of capacitors on this board that the amplifier needs to charge up in order to start turning on and come into operation. So also, I'm just going to clamp my oscilloscope probes to parts of this MOSFET so we can measure what's going on. So I would quite like to clamp one of these to the high side drive and also the low side drive as well. So if I get my other probe, and that should have, I'm looking for my other attachment. There we go. Other little clip-on attachment. I can't remember where the high side and where the low side is on this board, so I'm just gonna have to guess, but I might have to move these probes around in a minute. Okay, that might be right. That might do. Okay, scope, reject low frequency. Yes, that's correct. And we're on 5 microsecond, 5 US. And I'm going to go up to 50 volt divide because this is a big powerful amplifier. Turn my thermal imaging camera on, and I've actually modified my thermal imaging camera so it is plugged into the mains because it's only battery powered before and it used to drain batteries like within a week, and it gets very expensive. So I just hooked up a small 5 volt power adapter and soldered it to the internals of the board, so now I don't have to keep changing the flipping batteries all the time, which is nice. Okay, so I'm going to go ahead and power the amplifier up now. And I'm not going to drive my load yet. My load is on the RCA here. This signal is on the RCA, but I do have my dummy loads connected. So let's turn the amplifier on and see what happens. You can see there the rail voltage is starting to climb on the scope. Let me just confirm which probe that was. Okay, so that is the high side rail. Okay. So yeah, the high side rail is there. So the high side drive will be on either side of that. So if I probe the high side drive there, and then this one over here, the low side drive should then, in theory, be this one. He says, in theory, the low side drive should in theory be there. Okay, let's give that a go. Don't seem to be getting any low voltage rail. Interesting. No, this amplifier only has a high voltage rail, doesn't it? It only has a positive voltage rail. Okay. Okay, getting pretty high voltage now. We're 82 volts on the rail, so I have to pulse the remote a few times to get this thing to come on. So I'm just going to pulse it again. There we go. And you can see the switching wave is there now on the scope. So the amplifier is in operation. And we are drawing 7.4 amps, which is quite high actually, but this is a big amplifier, so it's to be expected. Now I'm a little bit concerned actually, because this is a brand new amplifier, but there's an area over here which looks to be like a voltage regulation area, and this is reaching 80 degrees already. So I noticed this earlier when I was having a look at this amplifier. So we've got 90 degrees already on one of the small ICs over here, and I don't think that's correct. I think this might have a fault already. But nonetheless, let's continue with our test, and if it explodes, it explodes, no worries. So yeah, now we have all of the amplifier powered up. All the FETs are switching nicely. They're staying nice and cold as well. The amplifier is running at idle. So what I'm going to do now is I'm going to plug in the RCAs, and the gain is turned right down here, and we're going to see the amplifier do some power into my dummy loads. Now I'm going to need to change where my scope probes are for this. So if I remove this probe, and I need to attach this to the speaker terminal output so I can actually measure the sine wave. I want to have a look at what the sine wave is doing as well to see the amplitude of the sine wave. That's going to be useful to me. So if I remove this scope probe from this one, and we're just measuring the high side drive from now on. And let's turn my scope to 2-second divide so I can read this wave going in here. Now this is a full bridge amplifier, so therefore this amplifier is like having two smaller amplifiers bridged together. So both positive and negative speaker terminal will be doing power, and they'll have half rail voltage on both speaker terminals, and they'll both have a sine wave on both speaker terminals. So when we probe the speaker outputs, it's going to look a little bit strange, but fear not, that's how it's designed to look. Okay, so on the screen now you can see the high side drive has come into operation. Amps drawing 7.1 amps again. So I'm just going to move this down a little bit. So we're just going to move that away so we can kind of just see the top of that wave there. I'm going to plug my RCA in just here. And you can see that a sine wave is just starting to appear on the screen. I'm going to AC couple this and zoom in a touch, so we can see the sine wave a little bit easier. It's quite a noisy, there's quite a high noise floor on these amplifiers because they're a Class D. So you can see there the sine wave is there. So now you can see that the current from the amplifier's drawing goes from 7 amps to 7.2 amps when I apply the sine wave. So that's not very much. So I'm going to just turn that up a little bit higher, get the amplifier drawing some more current. So we're now at 11 amps that the amplifier draws with the signal present. So if I take my thermal imaging camera, I can have a look at the FETs, and we can see them start to heat up as it does power into these dummy loads. So yeah, we're dumping a constant 10 amps into these dummy loads. Now these FETs, they might take a little while to warm up with this low output. So I'm just going to keep this going for a moment, and we're going to find out. Okay, the FETs are starting to heat up by the looks of things. Okay, let's remove the signal for a moment and let's just have a quick look at this. This thermal imaging camera is not great, it's a little bit of a crappy one. I wonder whether I can use this camera to show you what I can see on the thermal imaging camera. Okay, wait for it to focus. Maybe it will focus. Come on. Okay. Okay, so it's finally focused. So the FETS are still staying pretty cold. The hot areas that we've got on the board, this is the drive circuit. The drivers do run a little bit hot, you can see there. Drivers running at about sort of 40 degrees-ish. Yeah, the FETS are still... There's one FET over here. This FET here. Now this FET appears to be running at... This is so hard to hold both at the same time. So this pair of FETs here is running at 31 degrees. And comparing that to the others are running at 28 degrees. So that's within my little tolerance that I wanted earlier, 27 degrees over here. So that's within my little tolerance band. On the other side, this is probably going to be too hard to do it with the camera as well, but I shall try my best. Yeah, so the FET's on the other side. How are we doing on the other side? About 32 degrees, perhaps. I'm actually... This is really, really hard to do with the camera at the same time. I'm actually just going to turn the amplifier off. I'm going to feel for heat using my fingers here. Okay. Okay, so this actually does show up, and this does actually... Okay. Right. So... Just from that little bit of idle, so we had the amplifier was idling for a couple of minutes just now, and we were driving a very, very small signal into a 12 ohm load. Two FETs here, these two FETs have reached 35 degrees, between 34 and 35 degrees. These ones over here are absolutely stone cold, they're still room temperature, but these two are getting hot. Over the other side of the board, over here, we have these two getting slightly warm, and the others staying at room temperature. Okay, let's turn the amplifier on again. Let's increase the signal level slightly higher, monitor the temperature of these FETs, and let's try and get them a little bit hotter so that we can notice the differences a bit further apart. Wow, the amplifier actually went into protection just then. I wonder what caused that. Nothing's hot, so let's try and power the amp up again. That's interesting. There seems to be some kind of ground loop. Whenever I touch the ring on the RCA, it goes into protection. Maybe. Oh, this is strange. Let me keep doing this. This is a bit weird. Ah, okay, I see. Okay, so it just increases the signal level when I push the RCA in fully. So if I keep the RCA slightly taken out, then we get a low enough signal to... Okay, that makes sense. Oh, we've got 16 amps now going in. The amplifier is dumping into the dummy load, so we've got 16 amps being drawn from the supplies. And yeah, let's see these FETs get a little bit warm on the output section now. Yeah, no, the issue just then with my RCA was that I wasn't pushing it fully in before, and when the ground ring makes a connection to the RCA ring, it actually almost doubles the input voltage to the amplifier. So that's why it was going into protect, because it was just drawing too much current from my small supply here. which makes sense. How is your audio input setting RCA, or you cut speaker wires, add them to RCA? No, so my signal input is actually a frequency generator, but it uses, yeah, so it's just the RCA tips. It has like pretty much bare wire outputs, so obviously I've just got an RCA tip to bare wire connector and use that as the attachment here. Okay, I think I'm going to increase the input voltage to the amplifier slightly. So we've got 10.8 volts going in at the moment. I'm just going to increase that ever so slightly. So now we've got 13 volts going in, and this should allow the amplifier to do a little bit more power. This is really interesting. This thing is dumping 20. This thing's dumping 20 amps into these dummy loads, and the FETs are still staying pretty cold. So there's obviously like a lot of thermal headroom in these. Okay, so we've got these two FETs that were getting hot before. These are now reaching 37 degrees, 37.5. The others are still staying dead stone cold. On the other side, we've got these two that were heating up a little bit more than the rest of them. These are reaching 32 degrees, 33 degrees, whereas the others are still sitting down at 27 degrees. So it's quite obvious that the FETs, for some reason, the FETs closer to this side are getting hotter than the FETs further to this side. And it could be to do with the fact that the fans are actually here and they're blowing some crazy ass air. So I might actually just disconnect these fans. I'm going to go ahead and disconnect these fans because these could be actually skewing my results here, and they could be cooling the FETs which are closest to the fans. So I'm going to disconnect the fans just real quick. Because yeah, I've just noticed that the fans are very close to these FETs here, and so the air is going to actually circulate around these, which is going to be cooling them. So that might actually be skewing the results slightly. Good to see so many people in the live chat. I hope you're enjoying this. This is pretty interesting. This is not quite. It's not an amplifier repair. This is yeah, it's just seeing what the jam is with these amplifiers and seeing whether we have bad FETs in the output section that are going to cause us problems. I don't like the fact that they have different codes on them anyway, so I might swap them out all anyway. But if I'm honest, I was actually expecting worse results than this. This is going slightly better than I expected. I'm going to wait for the fans to... I'm going to wait for these FETs to cool back down to roughly where the others are, so I doesn't skew the results. Okay, I think that's probably just about enough. Okay. Hit the load. And let's wait for these FETs to heat up again. In hindsight, I probably could have used my Dell server power supplies, but with the Dells, I have absolutely no control over the current that they can pass. And if a fault was to develop with this amplifier and it was to demand excessive current from the supplies, those Dell supplies would literally be able to give them about 600 amps in a small burst, and so we could see a fire situation if something went wrong there. Okay, interesting. It appears that actually now the FETs seem to be heating up in a more uniform fashion. I'm going to compare the codes and see whether one code of FET gets hotter than another code of FET. So here on this side of the amplifier, I've got the W8s and the W9s. So do the W8s get hotter than the W9s, or are they both about the same? There's a W8 here that's getting way hotter than the rest of them. So this W8 is reaching 40 degrees. Whereas all the rest of the FETs on this side are only reaching, they're reaching 35 degrees. So we've got a 5-degree difference between one of the FETs on this side and the rest of them. So I don't think that was to do with the fans. I mean, the fans did have something to do with it, because the FETs on this side that were closest to the fans are now starting to get a bit warm. But they're getting warm mostly in unison. Hang on. How hot's this one? 38 degrees. Yeah, I don't think I can actually get these FETs hot enough with this small supply. I thought that I could. I thought that I could. Wow, man, some stuff runs fucking crazy hot on these amplifiers. There's a small section in the middle here. Something in the middle here that's running at 65 degrees. Part of this voltage regulation circuit is running at 90 degrees. 92 degrees. Yeah, 92.5 degrees over here. So this small voltage regulation circuit, that IC looks like it runs at 92 degrees. That's a bit too hot for me. I wonder whether this amp has some kind of fault or something. I don't know. It's a little bit too hot for my liking. Anyway, right. Let's remove the signal now, turn the amplifier off, and let's compare the heat. So, looking at the thermal imaging camera, on this side of the amplifier, we have the FETs which are closest to the oscilloscope probe. These ones have reached up to about 38 degrees, whereas the others over here are sitting down at 35. So that's a 3 degrees difference, not too bad. However, on this side, there's one FET here which was reaching about 42 degrees, whereas the others on this side were only reaching sort of 34 degrees. So that's like a sort of 7 or 8 degree difference. So there are some slight differences between how these FETs are sharing the power, and I can feel it with my fingers. There's not a huge difference, but there is a small difference between how these FETs are sharing the power. The ones on these two specifically are getting a fair few degrees hotter than the rest of them. So if you were driving this amplifier extremely heavily, you know, running like a 0.5 or 0.25 ohm load, and you were driving it for hours, if the FETs were ever going to die from excessive current, then these two would go first. Excuse me, I always mute the camera while the microphone while I sneeze. So actually, yeah, this test hasn't gone as badly as I thought. If I'm perfectly honest with you, I was fully expecting to be doing this test, and I was fully expecting to see like 2 or 4 of these FETs reaching like 70 degrees, and the others still sitting down at 28 degrees. But that's not the case. They are actually showing the load better than I thought. What I might do, so the next thing that I wanted to test, this is a brand new amplifier. This has never been repaired. These are the FETs exactly as they were from factory. It's never been blown. So what I was going to do is, if I saw any crazy deviances between the temperatures, is I was going to remove one of the hot FETs and I was going to remove one of the cold FETs, and I was going to test them both in my transistor tester here. And that way we could see whether the RDS values are different or whether they're roughly the same, and what the VT value is like, etc. So we can get a rough idea as to whether these FETs are well enough matched to work together in parallel in an amplifier. But if I'm honest, they weren't getting that much. The temperatures weren't crazy different. I don't think the temperatures were different enough for me to warrant pulling the FETs out. These boards are very delicate, and if I can avoid it, I'd quite like to avoid taking this board off if I can. You see here in the middle of the board, now I have already taken this board apart. The reason I took this board apart was because the power supply section was actually damaged by Brazilian customs. So they drilled some holes in the capacitors, and you can see here some of the caps I've replaced. The caps I've replaced don't have covers on the top, so I've used some tester tape to secure them. So they actually drilled some holes in some of these caps, so I had to replace a few of these capacitors here. As a result, I had to remove the power supply board, and I learned very quickly that this small jumper section here, bridging wires, is very, very, very delicate. Like, yeah, it's stupidly delicate. So I don't particularly want to have to remove like those again and remove the output section board. So I was going to try and do a top board repair where I remove some FETs just from the top of the board using I could use my long soldering. I could use this. So I have my soldering iron tip here. I don't want to, this still has some high voltage on it, so I don't want to touch that just now. But I could use this on here to desolder that quite quickly, perhaps. If I massively soak it in solder, I could remove that relatively quickly from there. So I might wait for the rail voltage to sink back down, and I might see if I can remove a couple of these FETs just to read them on the transistor tester and see what they are showing. Let's see, what's the rail voltage sitting at now? If I bring that back to 0 on my scope, turn off number 2. So the rail voltage has sunken down. It's sitting at 2 volts now. So yeah, the rail voltage is only at 2 volts now. So it's sunk down quite nicely. So if I just remove the rest of that by grounding it somehow, I can't remember how you. The rail voltage is here on this one, so I just need to ground that to the amplifier's main ground. Where I need a spare piece of wire. There we go. So that 2 volts has now disappeared. So if I see, I mean, this soldering iron tip is pretty old now. It might not be ideal for doing this anymore. It's actually pretty bent. It's pretty warped. It's not in the best of conditions. Oops. Get out of there, damn it. Yeah, RDS. Yeah, Paul Williams has got it spot on. RDS is resistance between drain and source, and it should be as low as possible for optimum operation. So if I put that there, that should desolder pretty nicely. Okay. Yeah, let's try this. I'm going to heat up that tip. It takes a little while to heat up. About 410 degrees Celsius. I'm going to soak it in solder. I'm going to see whether I can remove this FET from the top board. Do you have RDS on your transistor tester? Yes, my friend, I do. I do indeed have RDS on my transistor tester. Oh, that's a good sign. My dummy loads over here. My dummy loads here were getting nice and hot, so we definitely were dumping some power. yeah, they're getting pretty warm over here. So some good power was definitely being transferred. So I'm going to remove this FET over here, which was one of the ones that was getting hotter than the rest. And I'm also going to remove, that's a W8 batch, so it makes sense to remove a W9 batch next. So if I remove one of the W9 batches from over here, so let's remove two on the same side. So we're going to remove this one and this one. We're going to compare the readings in the transistor tester. Now sadly, I don't think it would be really nice if I had, let's have a look, what do I have in here? I was going to say it would be really nice if I had some brand new 90N20D FETs that I know are a good batch, like from a good reputable source, because then I can show you the difference between the readings that you should see and the readings that we might see from these ones. Okay, I think this has got pretty hot now. This tip is in a terrible condition. So I'm just gonna hold this on here for a while. I'm gonna apply lots of solder to each of the pins. Really cook her up a storm. I think this tip is actually curved in the middle where it's worn away, and I don't think it's actually touching that middle leg at all. Oh wait, we might have something. It might be starting to come loose just now. I don't want to pull it out too hard because I risk damaging the vias. This really isn't a good idea, you know, guys. Don't do this. If you're going to remove a FET, just take the board out. Here she comes. Here she comes. There we go. That wasn't too hard. This FET will probably now be crazy hot. So we'll see how hot this FET got just from doing that. I hope I haven't killed it from heat. He's a quite resilient FET, so probably be okay. But okay, so the FET is currently sitting at 115 degrees. From soldering. Yeah, I'd say that's probably fine. This FET should be able to handle 115 degrees without any problems of passive heat. So it's not active heat because it's not made the heat itself. It's passive heat because it's been applied to the FET. Okay, so let's put that down, wait for that to cool down a tad. And next, let's remove one of these over here that was staying cool. So I'm going to choose this one. Ah, no, my wire is not long enough. Okay, let's push this over a tad. Okay, just about reaches now. RDS is the reason I bought it. My transistor tester didn't read RDS. It looks the same as Sam's. I later bought a cheaper tester kit that had newer software and it tests RDS. Yeah, there seems to be a bit of confusion as to whether these testers actually read RDS. The one I bought, maybe I just got lucky. It just happens to read it from the word go. I didn't need to update any firmware. It just read RDS straight away. Yeah, I don't understand what the differences are between them. I just got lucky, I guess, with the one that I bought. There we go, and that's the second one out. Let's see how hot this one got from soldering. We are at 110 degrees, so about the same. Okay, so let's wait for these FETs to cool down just a tad. I'm just going to monitor their temperature. We can see one of them over here is still kind of crazy hot. So if I spray some isopropyl alcohol on these FETs and then blow on it, the evaporation of the alcohol will speed up the cooling process. Yeah, so we jumped from about 80 degrees down to 46 degrees just by doing that. So let's do that one more time. Okay, that was 46 degrees and it's now sitting at 35 degrees. So yeah, it's going a bit slower now. But they're cool enough to touch and to handle. So let's just put these on our hands like so. Touch them on the heatsink that's cold, that should help as well. Dissipate that heat through the heatsink. So for anybody that's just joined us, the idea of this live stream and this video, I will edit this video and upload it later on. This amplifier, this Banda amplifier and other Banda amplifiers appear to have come with MOSFETs in the output section that are counterfeit or a bad batch from factory. And I have proven this and resolved the issues with the Banda Viking 7Ks by just doing a complete refresh on the output section and replacing all of the 90N20D FETs with a decent batch known reputable source that read correctly on the transistor tester. All the original FETs from the Banda Viking 7Ks that I've come into contact with have really all over the place weird readings on the transistor tester. The RDS values are way too high as 11 or 22 ohms in some cases, and what happens then is that the FETs that have the lower RDS, they do the grunt of the power and they will then blow as a result, because all of that power is then being channeled through 2 FETs as opposed to being shared by 8 FETs. Now this is the next amplifier up. This is the Banda Viking 10K and it uses the same 90N20D FETs in the output section. So I pulled off the heatsink clamps here because I wanted to have a look at what batches they were using on the output section of the amplifier, and I noticed that they were using 2 different batches of FET. And the two different batches of FET were only 1 digit different. So they, going by the codes, they were made in the same factory or around the same sort of time and were just one batch away from each other in production. However, the markings on the FETs themselves, the laser inscribed coding, is in different fonts and a completely different style between these two batches, which doesn't make any sense. If they were both made in the same factory around the same sort of time, using the same, the same sort of general run, then they will have the same markings on them and in the same style, but they are not. They are different fonts and they are different different sharpnesses. So I believe these are potentially fake counterfeit FETs which have had markings inscribed onto them post-production or something along those lines. And the intention of this video was to remove the MOSFETs from the heatsink so that they are no longer able to sink their heat shared through the heatsink. Then I was going to apply some very, very small load to the output section. I was going to drive my dummy loads with a 45 Hertz, a 12 ohm dummy load, and we were going to monitor the temperatures of all 16 of these output FETs. And technically, in theory, any FETs that have a low RDS value compared to the rest of them will get hotter than the rest of them because they are doing the most of the power, and therefore it will show that the output section is imbalanced because of counterfeit FETs. In reality, I did the test just now on live stream and I found that the deviance wasn't that great. We had a pair of FETs over here which were getting to 45 degrees, whereas the others were only reaching 36 degrees. So there was a deviance in temperature, but I was expecting it to be much more severe than that. So after the test, I have just removed 2 FETs. Oh shit! Now which one was the bad? Okay, yeah. So the one that was getting hot was from here. The one that was staying cool was from here. So I have 2 FETs. One from the pair that were getting hot, and one from the pair that was staying cool. And the intention is to put these both in my transistor tester and measure their specifications, their values, to see whether they differ. If they differ by a fair bit in RDS or in VT, which is the turn-on voltage of the MOSFET, then we know that that is the issue that's causing the difference in temperature to present itself. Okay, so looking at our test number 1, this is one of the ones that was getting hot. This has a VT of 4.5 volts and an RDS of 1.3 ohms, which is a little high compared to the FETs that I usually buy, the 901020Ds. It's usually a little bit lower than that. So let's go ahead and test FET number 2, which was one of the ones from the cold batch. So this should technically be a higher RDS. Oh man. Oh dear, well there goes my theory out the window then. The VT is the same, 4.5 volts, and the RDS is actually slightly lower at 1.1 ohms. Okay, so the FET that was getting hotter has a slightly higher resistance. Now, this could also be correct. So there's, in my head, there's 2 ways that this could go. Okay? If we think about it, if we have, let's keep this simple. Let's say we have 4 FETs in parallel. So we have 4 MOSFETs all driving the same load. One of them has a 4 ohm resistance, and the other 3, no sorry, let's do this again. One of them has a 1 ohm resistance, and the other 3 have a 4 ohm resistance. So you've got 4 FETs, 1 ohm resistance on the FET, and 3 at 4 ohms. Now, my original thoughts were that if you drove a load between those FETs, then the FET that was 1 ohm would get hotter than the 4 ohm FETs because it's passing more power, because it has a lower resistance, so the current favours the path of low resistance. So the 1 ohm FET gets hot and the 4 ohm FETs stay cold. But possibly it's the other way round, because resistance creates heat. So in order for heat to be created by an electronic device, there has to be resistance, and usually obviously the amount of heat that's created is as a result of the amount of power that's being passed through that resistor. And usually the higher the resistance, the hotter it will get, but it needs the voltage to be high in order to do that. So if you've got the same voltage across four different loads, if you've got the same voltage across 4 different loads, then the load that has the lowest ohm would get the hottest because it's passing the most power. So that then doesn't make any sense then. So why were these two getting hot? Maybe it's because they're imbalanced. Because hang on a minute. Right, let's have a closer look at this. Let's have a closer look. I'm just going to put these FETs back to where they were, just for a second. So this is how the FETs were laid out. Let's wait for this to focus. Come on. Focus for me, baby. It will do it. Just give it a sec. And if I look over there and then look back over here. Okay, finally we focus. Right. So this is how the FETs were originally laid out. So I don't like to see 2 FETs from different batches used in parallel with each other in the same bank. So here we have a bank of 2 and a bank of 2. So the bank of 2 that was getting the hottest has one W8 and one W9. So this is the W8 and this is the W9, and these two were getting kind of hot. And I wonder if that's because they are both running, they're both being driven by the same drive, so they're both completely in parallel with each other, but they're different batches. The ones over here, which were staying cooler, are both W9 batch, so they're both the same batch. So I wonder whether it's not a case of RDS being different that's causing these ones to heat up a little bit more than the rest of them. It's just purely the fact that they are different batches being used in parallel. Yeah, but see, if that theory was correct, see, that doesn't make any sense either, though, because if that theory was right, come on, focus again for me, baby. Yeah, see, I don't think that theory is right either, because you see here we have another 2 pair of FETs, one with a W8 batch and one with a W9 batch. And so technically, if that was correct, that they didn't like being in parallel with each other, these two should also be getting hot, but they weren't. These ones were staying cold as well. So, yeah. Doesn't really seem to make a great deal of sense right now. I guess the only test that I can do next, which will be a pretty expensive test at that, I still don't trust these FETs. I don't like that they look different. They're the same factory run, slight different batches, but they have completely different markings on them. The marking style is completely different. I don't like that, and I don't trust it. So I would quite like to still replace all these output FETs with a known good set of FETs. I mean, both of those read 1.1 and 1.3 ohms in the transistor tester. From my experience, when I've bought good FETs from a reputable source of these 90N20Ds, the RDS is like 0.2 of an ohm on the tester, and it's up at 1.3 on here, so this is a little bit higher than maybe I would expect to see. So I don't like that anyway. But I would, you know, a good test to do would be, so obviously now we know by running this through a 12 ohm load, running 45 Hertz, doing the test for like about 5 minutes or so, a couple of the FETs are reaching 40 to 45 degrees. So that is our benchmark point. That is our benchmark point. We can do the same test, we can repeat the test again, and we can compare the temperature of the FETs. So if I replace all of these 16 FETs with a completely fresh set of 90N20Ds from a reputable source, if I do that, and I test it again, and the FETs don't reach 45 degrees, they only reach like 32 degrees, then that is a great improvement. The FETs are lower resistance, and therefore they're not getting as hot. Whereas if I replace all the FETs with a good known batch and they still reach 45 degrees, then that test was completely pointless. Yeah, so let's have a look in the live chat. S. Robbins says, I agree with him, the FETs need to go, all of them. Just swap the two you've removed. Yeah, I was thinking of doing that. I was thinking of swapping around these FETs so that they were matched, but from my test just now, the other ones that are different in parallel don't seem to be getting hot, so I don't think that that's the problem. Duel Allen says, couldn't they be gain matched at the factory, relying less on being from the same batch? No, the gaining or the current sharing of these batches of FETs is not controlled. It's not controlled in any shape or form, so they have to all be of the same specification in order to work correctly. What else we got going on in here? Sneaky Adam, would you still recommend this amp? Yes, this is a fucking amazing amplifier. This is a superb amplifier in terms of circuit design and the amount of components that they're using and everything. This is a absolutely superb amplifier, especially for the price you can get it at. And provided all the FETs are good, this thing is amazing. Yeah, definitely buy one of these if you want very, very loud bass and good reliability. The only reason that I have this one in the workshop is because Brazilian Customs mutilated it. They were looking for drugs and they drilled holes in some of the power supply capacitors, so I had to pull the amp apart and replace the caps and some other bits and pieces on here. But yeah, there's nothing wrong with this amplifier. But I was just curious to do the test with the output FETs because they look different markings. Mitchell says the FET spec sheet rates up to 175 degrees if they are 90 and 20. That's pretty cool. So I could test this much harder. I could plug this amplifier into the Dell server power supplies, and I could get these FETs up to about 100 to 120 degrees safely, and measure the difference in temperature at that point. That might be something that I do actually. I might do that next. I just don't like the. It really scares me. It scares me the idea of having the amplifier open on the workbench like this and having a non-current limited supply available to the amplifier to catch fire with. That scares me. I don't like that, especially with amplifiers like this. Yeah, that worries me slightly. Parts are cheap. I worked on consumer electronics for 3 decades, got paid by the hour. I would just replace the FETs and move on to the next issue. Says S. Robbins. Yeah, these FETs aren't that cheap. Let's see, how much would it cost me to replace all of these? Let's go to my secret website that I buy all my FETs from, Mercatio. And let's see, how much would a fresh set of these FETs cost? P 90 and 20D. So we've either got, so this is if we buy a shit ton of them, from 321, 63 per 25. So we need 16 of these bad boys. Okay, so that's £8. That's £2.81 from 10 pieces. Or if we buy these ones, how much is it for a pack of 30? A pack of 30 is 93.48 divided by 30. £3.11. So this set isn't good value. This one is good value. So if I bought 16 of these, which is what I need for this amplifier, is going to cost me £51.77, and in US dollars for all you guys, 51.77 GBP in USD. So at the moment, with the current exchange rate, it will cost me about $70 to replace all 16 of these output FETs. And yeah, okay, in the long run, it's not a horrific amount of money, but it's enough money for me to, think twice about whether this really needs doing or not. So, going by the test results of this test, going by the results of this test this evening, this is an amplifier that I'm actually going to probably be using myself. So, going by the results of this test this evening, I am confident to trial using these FETs in the amplifier and see how they go. The beauty of being an amplifier repair technician is if any of your own amplifiers blow, it's easy enough just to take it out, put it on the bench and repair it for yourself. So if this amplifier doesn't perform to my expectations, if the FETs die after some use, I will be using this amplifier at 0.5 ohms if I can, because it is very well suited to 0.5 ohms. This is a superb amplifier, a very high current handling amplifier. So 0.5 ohms would be no struggle for this amp. So I'll be using a 0.5, and so if any of the FETs die, the protection circuits on these are very fast. If the FETs die, the power supply section never gets cooked. So I should just lose a pair or more FETs from them dying. If that happens, I'll replace the whole 16 of them. I'll spend my $70 on a fresh set of FETs by 16 of these, and then try again, and then the amplifier shouldn't die again. So let's put these FETs back in the board, screw her back up, and wait to install it in my vehicle. Yep, some good stuff in the live chat. Replace them all and do another test. Yeah, I'll do that, but it's going to cost me $70, so maybe sometime. Yeah, so basically Brazilian customs, they love looking for drugs, and so I actually had 2 amplifiers shipped from Brazil directly to the UK. Both of those amplifiers were damaged by Brazilian customs, and yes, they drilled holes not only in the capacitors, they also drilled holes in the fucking heatsink. So one of the other Banda amplifiers that I've got has a great big fucking drill hole in the front of the amplifier in the heatsink. It's fucking ridiculous. Can you take like a claimed 2K amp and upgrade it instead of buying a true 2K? It depends. You can get a bit more power out of the amplifiers by making some modifications, but only if you run the amplifier at lower than recommended impedance. So if it's a 2K at 1 ohm amplifier, sorry, if it claims 2K at 1 ohms, and let's say you want to get 2.5K out of it, but in the amplifier's current state from the factory, it's not happy running at 0.5 ohms. It goes into protect, or it blows the MOSFETs, or whatever it does. It's not happy. It doesn't like running at 0.5. There are some modifications you can make to the amplifier that will improve its performance at 0.5 ohms, which will allow you to get that 2.5K, 2.8K, or maybe even 3K out of your claimed rated 2K amplifier by running it at 0.5. The complicated bit comes if you want to try and increase the amplifier's power while keeping the load the same. So if you have an amplifier that does 2K at 1 ohm, but you wanted to do 2.5K at 1 ohm, That's not as simple. That's much more complicated, and it's those sorts of upgrades that are not worth doing because they cost too much and they take too much time for what it's worth. You might as well just go ahead and sell your amplifier and buy one that suits your needs. But there are some modifications you can do to improve the amplifier's performance at high current and low impedances. And some of those mods aren't actually too complicated. Okay, so that's the holes sucked from the solder, so I can go ahead and put these FETs back in place now. I'm going to swap them around. So I'm going to put the W9 in next to the other W9. I'm going to put the old W8 in the other side. Sharky O, that's yeah, thanks for the kind words there, buddy. Wait, hang on, 900 critics? What do you mean how many people are watching this live stream? Oh, okay, so there's 80. Oh, I got all excited there. I thought I had 900 viewers. That would have been fucking crazy. 900 viewers on live. That would have been pretty impressive. I always know when wait, where's my I always know when Seth is in the live chat because it all goes orange from donations. Hello Seth, good evening my friend. Thank you very kindly indeed for the $20. So actually Seth has donated $20 this evening. So now if I was to replace all these FETs, it would only cost me $50 because Seth has given me 20. So yeah. I hope I haven't screwed anything up by removing these FETs. What do you reckon? Do you reckon it's my bad luck that when I put these FETs back in and I turn it on, it explodes? That's the sort of luck that I get sometimes with this shit. Chevy's not Hondas. How is it going, my friend? Hope you're good. Okay, let's make sure I haven't made any solder bridges before I turn this on again. Yep, no, we're looking good, nice and safe. No solder bridges there, my friend. Okay, so let's wait for those to cool down, and let's get rid of some of that solder flux between these pads. Yeah, Sharky, I agree. Absolutely, yeah. I would love, yeah, if they removed the pull-down resistors and so that the capacitors were filled with like 200 volts and they were just drilling into this, getting a nice surprise when they hit a 200 volt charge cap. That'd be great fun to see. What kind of soldier do you use? I use a well-trained commander. No, I use leaded solder, 60/40, tin lead. I tried unleaded, but it's rubbish. I have a Boss amp that has 8 outputs from factory. There's 2 extra spots on the board where the gates aren't in it, and 2 spots for more identical FETs in parallel. Would adding 2 to the bank make more output or waste money and time? So Modbox, by adding 2 extra FETs there, it won't make the amplifier do any more power at 1 ohm or whatever the amplifier is rated for. So you won't notice any difference in the power from the amplifier. However, it will make the amplifier more reliable and more stable at a lower impedance. So if you wanted to drop the amplifier down to 0.667 or 0.5, then running the extra FETs in the locations where they are missing will help. Seth, am I tuning in late? Yeah, I think so. Yeah, we've been streaming this for about an hour, I think, so far. How long has this stream been going on for? Yeah, 1 hour and 16 minutes, so not too bad. Sam, could you answer my 640N? Josh Hansen, where did I miss that? Oh, here we go. Oh, Sam, is an RF 640 the same as a 640N? No, it's not. A 640 has a die size that's about twice as big as a 640N. A 640 is actually technically a slightly better part than a 640N. Well, I say it's better, it's older, and it has a bigger silicon die. But the 640N is much more modern and has better specifications. They're both much, but given the choice in modern car amplifiers, you should use the 640N. Okay, so I think this is all cooled down. Yeah, that's nice and cool now. So I'm going to return. I'm going to do the test again. We're going to repeat the test. And we're going to see whether swapping those FETs around has made any slight difference to how this amplifier works. Okay, amp's up and running. Actually, interestingly, already we can see that the amp is actually drawing slightly less idle current. 6.8 amps on idle. So that's yeah, it was drawing 7.2 amps before. That's a pretty curious thing to note. So if I do end up replacing all 16 of these FETs with the different batch, the brand new ones, from a reputable source, it would be interesting to compare the idle current. That's interesting. It seems that these FETs are actually getting hot on their own accord. So I haven't even applied the load or the RCAs yet, and this pair of FETs here, these are getting pretty hot. So these are 35, 36 degrees, and the others are currently sitting at room temperature. Yeah, so that's not good. Yeah, so this pair here, this is reaching already hotter than ideal temperatures, and we haven't even started driving a load yet. So the fact that those are heating up like that is not to do with them doing power. It's purely an imbalance. So the only reason that FETs would heat up when they're not being driving a load is if there is an imbalance in how they are being driven, or the VT, the turn on voltage. So they're, you know, one of them is being turned on quicker than the other or something. So let's now apply some signal to this. And let's see if they get even hotter. So all the FETs along this side seem to be pretty well matched. They're all heating up to about the same temperature. We've got 38 degrees on the pair of FETs here that are getting hotter than the rest of them. Okay, so the two hot FETs are now at 39 degrees. The others on the same side are at 38 degrees, 37, so they're not that far off each other. Okay, that one's at 36.2. This one's at 39.1, so they're about 3 degrees different from another. The ones over this side, we've got 39 degrees on these two. Okay, so yeah, they're all reaching roughly similar temperatures, so I would say for the time being, it might be interesting to run this amplifier without changing the FETs, keeping the original ones in here, and just seeing what it does. If people really want me to, if people are really curious to see what difference changing the FETs out for completely uniform batch match FETs makes, then I will order 16 of those, which will cost me 70 bucks, and I'll do the test. If people really want to see what the difference it makes, I will do it. But it obviously won't be in this live stream because I don't have the FETs yet. Ooh, look, check that out. Another $10 from Seth, man. Wow, I'll be sending quite a few super chats tonight if others do the same. Very kind of you, Seth, man. Thank you very much for the shout out. And the 10 bucks. So that's 30 bucks towards our FETs. So if I end up with $70 worth of donations this evening, then I may as well go ahead and order those FETs and do the test for you. So it's... Whoa! Okay, something happened there. I wonder if my power supply overheated or something. Maybe not. I don't know. I think actually my power supply may have actually overheated slightly then. I thought that I had blown something. I thought I'd blown something, but yeah, this power supply probably isn't designed to do 20 amps for like a continuous amount of time. It's probably a bit much for it, so... Ah, good job, little power supply. How hot are you getting? It's got a fan built in. It is kicking out some heat. Actually, yeah, it's kicking out some pretty good heat from the back. So, yeah, I think to be perfectly honest, I think these FETs are just going to reach, on this small power supply, these FETs are just going to reach 40 degrees, and they're just going to sit there. They're not going to get much hotter than that without plugging in the big Dell server power supplies, which I don't want to do just yet. So. Okay, cool. What I might do then is I might run this amplifier for a while in my new vehicle. Oh shit, did I give it away? Did I give my surprise away? Hot dang it. I might run this amplifier for a bit and you'll see some videos of this amplifier running in something interesting I've got for you guys. And if the amplifier does blow, then I will replace them all and we'll do more of these tests. So I'll show some old footage from this live stream and I'll merge it with the new footage if I decide to replace these FETs. So you guys can see what the difference it makes and whether the FETs that Banda are using in this are actually dodgy or not ideal or slightly counterfeit or slightly bad batches. Because if they are, then you can get better performance and better reliability from your amplifiers, the Banda ones, by just replacing the output FETs. I'm still not sure about this small area here reaching 90 degrees. That seems a bit much. I was going to see if I could get some small heat sinks for that, but yeah. Sneak Adam, can you ask my question earlier? Thanks. If you do replace them, do another live stream. Here we go. Some amps have clipping indicators on the side of the amps. How and where are these located and hooked up? So a clipping LED on an amplifier is very simple. All it is it's a comparator. If you don't know what a comparator is, Google it, look it up. It's a small chip, and what it does is it listens to some voltages, and then it has an output pin that goes high or low depending on what's on the two voltages it's comparing. So a very basic comparator, let's say it has 3 pins. It has input 1, input 2, and output 3. So what it will do is it will listen to the two inputs, input 1 and input 2. And if input 1 reaches the same voltage as input 2, then output 3 will be high. Whereas if input 1 is lower than input 2, then the output 3 will be low. So it's like a logic gate almost. It's a kind of yes no kind of thing. That's how it's used on the clipping detector. So what it does is the one of the comparator inputs is tied to the rail voltage. So the comparator is listening to the rail voltage. So the rail voltage is at 80 volts. Okay, so the audio sine wave can't pass 80 volts because that's the rail voltage. That's its ceiling. That's its headroom. And input 2 of the comparator is tied to the output sine wave. Now obviously if the output sine wave reaches and touches the rail voltage, then that means the amplifier is clipping because it's being clipped off because it's hitting the rail voltage. So the comparator will listen to both the rail voltage and the sine wave, and if the sine wave touches the rail voltage, then both input 1 and input 2 will be the same voltage, therefore the output pin 3 will be high, and that will then drive an LED to flash. Simple. Oh yeah, and ground pin. Yeah. Ground pin makes pin 4. I don't work on home amps at the moment, no. Maybe in the future, but at the moment, just car amps. What transistor tester model is that, Sam? It is one of these. There you go. David, you can't beat that dude that hit 150 dB with just two little 6.5 inch sundowns. Yeah, that's pretty impressive. I saw that. Yeah, very nice. Joseph says, I want to see if this amp will do true power at 14.4. Thinking of grabbing 215Ks. Yeah, these do make rated power. Unfortunately, I personally am unable to show you that because in order to make this thing do its rated power, which is about 13K at 14 volts, I would need a power supply capable of providing about 20,000 watts RMS of supply, which is just, you can't, you know, you don't have that in a workshop. You'd have to be rigged up to a factory power mains input from the fucking... Yeah, no chance. No chance. How do I get RDS to display on mine? Yeah, Prince, a lot of people are saying that they have the problem where RDS doesn't display on their tester. I don't know the solution to that. I just bought mine and it came and it showed the RDS. There is no magic way. It just displayed it automatically for me. So I don't know. I think some of these do and some of them don't. So I guess if yours doesn't, then you just bought one of the older ones or something. I don't know. I'm not sure. Sam, what's wrong with the US amps? I might be able to help. Yeah, you keep asking about the amplifier. I'm not going to work on it. My workbench is not big enough. I can't work on it until I redo my workshop. So that won't be for a long time that I work on that US amps. On my transistor tester, yeah, I'll tell you what the firmware is. I have to short the two. I have to short out all three pins. One sec. I need a bit of metal or something. God damn it. Right, there we go. Version 1.12K. I have no idea what this mode is. Oh, no, yeah, I do. I think that's capacitor plus ESR at TP1-113 ratio. That's a regular capacitor reading. That's capacitor microfarad correction. I can measure frequency, and I've also got frequency generator built in. I've also got a 10-bit pulse width modulator built in, so I can use this thing to drive MOSFETs effectively. This is the data. This is the data of this one. Version 1.12K. Ha! Ah, now here's something really cool, guys. I'm going to show you something really cool. So, one of the very, very kind gentlemen on my live chat, named Dan Doriot. I see him on the live chat just here. I'll highlight his comment. He shipped me from the States for free a very, very cool and interesting looking solder sucker. Now, this is essentially the same as I'm turning my tester off here. One sec. Now this is essentially the same thing as a regular desoldering pump. So regular desoldering pump, obviously you depress it, loads of spring, and then it creates a vacuum on the end which sucks any solder up inside the chamber. Now this thing works in exactly the same way, but it also heats whatever it is you're going to suck, so you don't have to hold your soldering iron at the same angle as well. So it has a heating element, has the hole on the end, and it also has the pump spring-loaded mechanism which creates a vacuum on the end, like so. So you can see there it's creating a vacuum on my finger. When I release my finger, releases the vacuum. So that's working quite well. It's creating quite a good vacuum inside, and that would be very useful. But alas, I live in the UK, the United Kingdom, Garden of England. So I cannot use this because A, this is the wrong plug, and even if I change the plug, this is actually only rated for 110 volts AC. However, look what I have here. I have a fucking big amplifier. Now I believe that this amplifier will kick out an AC voltage greater than 110 volts AC. So I could essentially run my desoldering gun on my Banda 10K amplifier. All I'd have to do is I'd have to play a continuous 50 Hertz sine wave, and this thing would work. I might be tempted to try it actually. Should I try it? Do you guys want to see whether I can actually power my desoldering gun on a Banda 10K amplifier? Would that be really cool to see? Would you like to see that? Either way, I'm going to just put these back on the heat sinks. I'm going to put these clamps back down because that needs to be done anyway. Lots of people are saying, do it, do it. Okay, I'm going to do it. But in order to do it, I just need to put all these MOSFET clamps back. So I'm going to put the MOSFET clamps back on first. That'll take me a couple of minutes. Feel free to ask me any questions you've got in the meantime while I screw these back down. And then I'll cut the plug off of the desoldering pump and I'll hook it up to my amplifier. Inexperience with Darlington transistors, trying to repair SoundStream that uses them. I may have used Darlington transistors, but I'm not familiar with them by their name. Apologies, I didn't go to any electronics school or anything like that, so I didn't learn a lot of the basics. So my knowledge of electronics is solely based around my experience. So I don't know a lot of the correct terms for some of these parts and stuff like that. So give me an example of a Darlington transistor and I'll tell you whether I've repaired an amplifier that uses them. Cody says, what's the resistance of it? Right, Cody, you can work that out, my friend. So, if anybody wants to work out what resistance this desoldering pump will present to my amplifier, you can actually work that out. So this is a 30 watt device, and it runs on 110 volts AC. So, I'll let you work that out. How many ohms is this going to present to my amplifier? 30 watts, 110 volts AC. Nice bit of easy math for you. A Darlington transistor are 2 transistors in one. Okay. Just a double transistor with the output driving the base of a second transistor, but in one transistor. Sharky says, you're welcome to my UK version of the same desoldering circuit. I struggle with it. Oh, that's very kind of you, my friend. Thank you for the offer. I think I'll see how I get on with this one. We're going to put this thing to the test and see how good it is. Running on my Banda amplifier here. If it works, if it's any good, then I'll either get an adapter, or if you really don't like using it, then, you know, to save you throwing it away, by all means, I'll accept a donation of that. That's no problem. But maybe watch this video and just see how well this one works. Maybe there's a technique thing or something, I don't know. Ah, shit. I hate dropping things in the workshop. I never find them again. You can see why it takes so long putting these clamps back on. This is probably one of the longest parts of amplifier repair. If you've got a big amp, then reassembling it is actually one of the longer parts of the repair. It takes fucking ages. Ugh, what's going on in the live chat? Whoa! Holy shit! Holy shit! A 50 from Seth, dude. Thank you very much indeed. Wow, that's really made my day, my friend. Thank you very much. That's actually now enough money to buy 16 new MOSFETs. So Seth has Seth alone has donated enough this evening. Thank you so much, Seth, man. That's fantastic. Has donated enough alone for us to afford 16 of these fresh FETs. So would you like to see me purchase 16 of these FETs and load it up and see the differences? Would that be useful to you, or would you prefer I spent that money on some other kind of tests, something else, some other thing that's maybe interesting? Because if I'm perfectly honest, I don't think that this test is going to be particularly interesting. I think that if I buy, I think these FETs are probably good enough, and if I were to buy some fresh ones, I think the results would be pretty similar to what we've got in here already. Like, maybe slightly more reliable, but I don't think we're going to see a great deal of difference in the temperature on these. So what would you like to see me spend Seth's donation on? I'm trying to clean the thermal paste off the amplifier, but I'm just spreading it around. Come on, you bastard. There we go. Right, so before I power it up, I'm just going to make sure that I haven't made any short circuits to the heatsink, because there was some loose bits of solder floating around, so it's a good idea just to make sure that you haven't made any continuity to the heatsink. Nope, I think we're all good. Can you replace the gain switches easily? Yeah, in these Banda amplifiers, it's not too difficult to replace the gain switches. The gain switches on these amplifiers are they're just here, so it's actually underneath the amplifier board. So it's flipped obviously the other side. So when this focuses, come on. There we go. Yeah, so the gain knob is just on the underside of this board here. Pretty easy to replace, yeah, just desolder and resolder a new switch on. Not too bad. Ah, Tom sends a 5. I can't compete. Well, here's the rest of that drink from yesterday. Tom, thank you very much, man. That's fantastic. Yeah, I think that definitely will buy me 2 drinks. So, let's go and see whether I have any drinks, because I always do like to have a drink on live stream, and I'm feeling in a good mood this evening. This has been quite a good live stream. So, I'm going to go and see if I've got a beer or something I can grab, and I will drink. I will cheers to Tom. So let's see what I got. So sadly my fridge seems to be pretty devoid of nice drinks at the moment. All I can find is this very feminine vodka lime soda mix, which is a 5% volume. It's not going to do anything. There's also this lemon liqueur, which is a limoncello. Now this looks quite appetizing actually. This is in a nice kind of, this is in quite a nice bottle. It's like a kind of misted bottle, and it's been in the fridge, so it's nice and cold. It looks very refreshing. Lemon liqueur, it's 22%, so, no, sorry, 27%, so I could probably drink this straight. This is the sort of thing you get in an Italian restaurant after a meal. So I'm just going to see what this tastes like, see whether it's drinkable straight. It might be a bit too sharp, a bit too bitter. But I might be able to actually add some to this. Vodka lime soda with a bit of lemon liqueur. That might be quite nice. Yeah, that's actually very drinkable. It's very sweet. It's probably a bit too thick on its own. It's quite a thick liqueur. So what I'm going to do is I'm going to probably just add some to this. Yeah, I need to go to the shops and actually stock up on some man drinks. I've got some wine, but my throat feels kind of sore, so I want a cold drink. I love red wine. I'll drink it by the gallon, but right now I kind of fancied a cooling drink on my throat. It's a bit sore. Yeah, this just tastes like lemonade. This vodka lime soda literally tastes like lemonade. I could give this to a fucking 5-year-old cousin and she would think it was lemonade. Okay, so we've added some of the limoncello to this, so we'll see if that improves the taste a little bit. Fix the Band. I've been curious about Brazilian power. Yeah, these amplifiers are actually fantastic. So the Banda amplifiers from all of the different Brazilian brands that I've seen have the best circuit design. It's just a shame that some of them are let down by poor FETS on the output section. Treat us all to a better webcam. Yes, guys. So they're right. So the reason that the quality looks quite low at the moment is because my computer is very old. It's an LGA 775 build, so it's running in a Xeon 5470 overclocked to 4.2 gigahertz. It's using DDR2 RAM, and I've only got a I've only got a 560 Ti graphics card. So it's really old tech. And the problem is that the CPU and the USB bus, whatever is controlling the USBs, isn't good enough to process all of this video data from all these different webcams and all these different camera sources and render it in real time to go to YouTube. So before, I used to upload at about 4000 kbps. At the moment now, with the new cameras, I'm having to only upload at 2000 kbps. I'm going to try and switch to 4000 now, just to see if it works today. Sometimes it works, sometimes it doesn't. So I'm just switching to 4000 now. You may or may not notice a difference in the video quality. Probably not. But it's now running at 4000 kbps, whatever you call it. Yeah, you know what? Eventually, the plan is to get some much nicer quality cameras for you guys. But for the time being, this works well enough. You can see what I'm doing, and I zoom in on things that are like, so the zoom in camera works fine. It just takes a little while to focus sometimes. But yeah, you know, it does the job. Spend it on things for your shop. Yeah, so I think in that case then, we'll put it towards I'll check this out. I'll check out how this works. If this works really well, then I'll use this and I won't bother buying the Hakko desoldering gun because that's quite an expensive investment. If this works well and does me for what I need, there's no point buying a Hakko desoldering gun. Might as well stick with this. The next thing for the workshop, to be honest with you, the thing that I want to do the most in the workshop is to take a week off work and redo the workshop, make it look really nice, give myself a lot more space, make it more customer friendly. I think I have most of the equipment that I need. I could do with maybe a slightly more powerful soldering iron. So I think my soldering iron is, I think it's 80 watts at the moment, maybe. Getting 130 watt would be quite nice. It does the job for what I need at the moment though, but yeah. Another 10 from Seth. Holy crap. Seth is just fucking balling it tonight, man. Fucking balling it tonight. Jesus. Thank you very much, Seth. Not that you have to spend it on your shop. Spend it on what you love. Pretty much, I do love doing this. So, most of my money ends up being spent on my workshop or on audio hobbies in general that you guys will get to see. Actually, you know, I'm quite liking this live stream this evening. I'm feeling like we've got a good vibe going on in this live stream. Maybe I'll give you guys on tonight's live stream a sneak peek that nobody else will see of my surprise. What I've bought for you guys. Would anybody like to see my surprise? Sneaky Adam. Yeah, the PC is fucking really bad. 200 bucks on the CPU would make a difference. Yeah, for sure. Problem is I need a completely new system. I need a new motherboard, I need new RAM, new graphics card, new CPU, new everything. The tech is so old that I can't reuse any of it. Well, I could reuse the 560 Ti, but even that's really old. Bear just said about Banda, good design, dubious quality components. Yeah, absolutely. The Bandas have the best circuit design of all the Brazilian amplifiers I've ever seen. Haha. No, I'm not pulling out my willy as a surprise. No. Okay, okay, so I'm going to do two things on this live stream now. The first thing that I'm going to do is I'm going to screw this amplifier back together. I'm just going to screw the rear case back on. And I'm going to test out the desoldering pump. I'm going to power it with the amplifier. And we're going to see if it works or not. Just before I screw the back case on, I'm actually going to flip it over just to get rid of any small bits of solder that fell in by mistake. That's always a good thing to do. Once you've finished work... My stream has actually just dropped out twice. If it does it a third time, then I'm going to have to look at my phone data connection to see. Right, okay, I think I've found the issue. I think I've sorted it. We're back up and running. Sorry about that, guys. Right, right, let's put this back together. That goes on there, like that. Another thing, I actually have, I bought a new broadband package, which should be quick enough to live stream from. So I shouldn't need to use my phone to tether from anymore. And not using my phone to tether anymore should also improve the quality of my live streams, because my computer is obviously using the USB bus in order to upload the data through my phone's tethering. So by taking that load off of the computer's processor, sending all of the data through the USB bus, it should technically improve the performance of the rendering. What's that hitting? Yeah, so basically I should be able to render at a high quality and upload through my faster broadband. So the quality of the stream and the reliability of the stream should improve greatly. I'm going to test it out over the next couple of days by doing some private live streams to myself and check the upload speed and check how often it drops out. But yeah, the streams should get better from now on, provided that works well. How many hours do you feel you played with amps before you had a good grasp of what you were doing? Oh god, probably about 3 or 4 months continuous, like every single day, because I wanted to make this my day job, so I pretty much dropped everything else other than the audio distribution and the sales and stuff, and just spent hours and hours fixing amplifiers that I bought that were blown myself, and just learning that way. It did take a while, it does take a while. But yeah, you get there eventually. Okay. So what we're going to do then is we're going to cut the plug off of this this desoldering gun. Bye bye USA plug. It was nice knowing you. And I'm just going to strip the cable so we expose the live and neutral. With my very, very blunt Stanley knife. I could do with a new Stanley knife blade, actually. Okay, and we're going to strip the neutral and strip the live. Okay, let's connect her up to my amplifier. This is going to be interesting, isn't it? This is going to be really cool. Now, can you guys tell me, I need you guys in the States to tell me, what frequency does your mains operate at? Is it 50 Hertz or 60 Hertz? Because that depends what frequency I put into this. I got a feeling you're 60 Hertz, aren't you? I got a feeling you're 60 Hertz. Okay, cool. 60 Hertz it is then. So let's turn my frequency generator up here to 60 Hertz. There we go, 60.2. Ah, 60.07, that's even better. Now, just before I plug in this last one, I'm going to obviously need to calibrate the output voltage on this. So if I turn the amplifier on, set my multimeter to volts AC, like so. So we need to see 110 volts on here, on the volts AC. So, okay. You have a variable desolderer if you have a variable gain. Yeah, absolutely. I do. If I obviously I can vary the gain of this amplifier, and I have a variable power desoldering gun. Yeah, absolutely. Yes, Daniel, thank you for reminding me. I did reconnect the fans by the FETS. Okay, so yeah, let's give this amplifier a bit more voltage. So we're going to put 14.7 volts into this now. And let's get it turned on. Okay, the amp's working in switching mode now, so let's plug in the RCAs. And we have 32 volts AC, which you can see here on the multimeter. If I turn this up a little bit here, you can see. So what I need to do is I need to increase the gain until that shows 110. There we go. 109.1, that's close enough. Okay, cool. So that's now calibrated for this desoldering gun. And that's at 60 Hertz. So if I take this cable here and plug it into the other side. There we go. So this is now hooked up, ready to go. I'm going to also plug my my oscilloscope in so you guys can see what's going on. If I do, what am I doing? DC AC coupling on both of these. 50 volts. Do that and do channel math. Okay, I thought it was going to be easy for me to click this on. One sec. I'm going to click my scope on so you can see what the scope looks like as well. Okay, there we go. So the scope is connected, and it looks like... Do we already have some voltage here? No? Yeah, okay, cool. So, this is the moment of truth then. Let's see if this turns on and see if it actually heats up or not. Let's take a donor board real quick. Something that we can desolder something from to see how well it works. How about... What have I got? I've got this JBL GTO 14001 board. So if I take this and we can try and desolder a couple of the capacitors maybe from this or something, yeah. Yeah, let's try and desolder a couple of the resistors from this. So if I just pop this on here. Okay. So yeah, let's get the amplifier turned on. Okay, cool. And now we apply the RCA and this thing should come to life. Drawing 6.4 amps. We've got a great big sine wave there you can see on the screen. I'm going to use my thermal imager to see if this is heating up or not. Ah yes, it's starting to heat up. Yep, it's starting to get hot. So it is working. It is going to work. Ha 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 ha! Powering mains devices using a car amplifier for the fucking win. Where's my drink? This is fucking cool. Yeah, look, it's actually blowing out smoke. Look, I don't know if you can see this. I'm not sure how hot this is meant to get. It's currently sitting at... I mean, this is telling me that it's currently sitting at, what, 70 degrees, maybe? So we've got to wait for it to heat up a bit longer first before we can use it. I love the little smoke that comes out of it. Poof! Choo choo! Tricks is very funny. I just use 10 car batteries and quickly flick a toggle switch on the back and forth to generate my AC. I like it. Rowan, this amplifier belongs to me. It's my amplifier, so don't worry, this is not a customer's amplifier we're messing around with here. So we're now at 94 degrees, so that's nowhere near hot enough to start desoldering yet. Just for reference, okay, just for reference, let's compare the temperature of this. So this has been on for a couple of minutes now. So I'm going to turn my normal soldering gun on, my soldering iron on, and let's see how quickly does the normal soldering gun reach and surpass the temperature of this other one. So I've turned it on now. So the one on the desoldering pump is at 80 degrees. My soldering iron is now heating up slowly. Okay, desoldering gun is now at 120 degrees. No, and my soldering iron has just passed it. My soldering iron is now on flipping 170 degrees and climbing. And yep, it's now at 200 degrees. My regular soldering iron is now at 240 degrees. (260 degrees), and the desoldering pump is still sitting down at 105. Okay, so is this still heating up, or has this reached its limit already? So this is now sitting at about 100 and... This is sitting at about 117 degrees Celsius, which is not that hot. I don't think that's going to be hot enough to desolder anything. So, I wonder whether I can supercharge this. So you guys know photonic induction. Don't tell me you don't know photonic induction. Of course you know photonic induction. Fucking amazing channel. He runs lots and lots of volts to household appliances. So I wonder whether we can crank this baby up, whether we can supercharge this to get it hotter than it was ever intended to. So at the moment we've got 110 volts going in there. So I reckon we could shove 150 volts into this to get it to heat up quicker and run better. What do you think? So this is currently running at 109 volts. So let's get my thing back. Let's get this back. Okay. So shall I increase the voltage to... So I'm just going to go up very, very slowly. Very, very slowly. I'm just going to increase the voltage in this, because this is very, very sensitive to increments. Ah, that's more like it. We're at 140 volts. Sorry, 140 Celsius. But we still want more. We still want more. I'm not having it. I'm not having it. Let's give her a little bit more. (131 volts). You see, the thing is, I don't want to blow it up, because I don't want to blow the amplifier. Like, if this shorts out, this is going to kill my amplifier. Potentially. It might not kill the amplifier, but I don't want to risk it. Actually, I have a current limited supply. Look, this thing is still only drawing 7 amps from the supply. Okay, what have we got now? So we've got 130 volts going in. And we've got 160 degrees Celsius. That's not enough. I'm not having it. I'm not having it. Till it pops, boys. Till it pops. I should probably have a Stella, shouldn't I? I should have a Stella beer. Okay, so the amplifier is actually starting to clip. As you can see on the oscilloscope screen here, we have reached the amplifier's voltage limit. So the amplifier's voltage limit is starting to get reached. We are starting to reach the rail voltage, so I can't actually go any higher with the voltage than what we see on the screen here, which is 135 volts because the amplifier is into clipping. So I would need, in order to do this test better, this is a 1 ohm amplifier, so it would be better actually to use a 2 ohm amplifier because the voltage would be higher. I don't need current for this test, I need voltage. So if I could have like a 10,000 watt 4 ohm or 10,000 watt 8 ohm amplifier, then that would actually work better than this. But let's see if we can desolder anything with this. So let's put the pump down. So we're quite hot at the moment. So let's try and remove a couple of these resistors. Oh yeah, the solder melts quite quickly. But it's not quite hot enough to keep the solder melted once we start pumping. Okay, so it works on this small resistor. This small resistor works quite nicely. Now I say that it's still much slower than using my my regular soldering iron and manual pump. Okay, let's try something else. Let's try a smaller component over this side here. Focus, focus, come on. There we go. Yes, it kind of works. Like, it kind of works, but it's really, really slow, and it takes forever to heat up. So in reality, it's probably not that practical. It's much quicker for me to grab my regular soldering iron and manual pump and do it that way. It just doesn't get hot enough. Someone said increase the cycles. So rather than increasing the voltage of the frequency generator, someone's suggesting that I could increase the frequency. So if I increase it from 60 Hertz to say 70 Hertz, what difference do you think that'll make? I don't think the frequency will help. 60 Hertz should be more average wattage. Well, let's try increasing it to 70 Hertz and see what happens. So we're now at 70 Hertz. Let's see if it makes it get any hotter. Lower equals more heat from a slower duty cycle. Oh, okay, lower frequency should have the same effect as a speaker voice coil. So it's currently sitting at 175 degrees. So if I lower it to 50 Hertz, you think that might make it have more power? So I'm just giving it 48 Hertz just now. I mean, it's staying at the same temperature. It's not actually getting any hotter or cooler, so I don't think it makes a vast deal of difference. Okay, I think that'll do. I think we've discovered all we can about this, and yeah, I think we've discovered all we can about this, and yeah, it's pretty cool. It's a really nice concept, but for my purposes in the workshop, it probably doesn't get quite as hot as I'd need it to, and it doesn't heat up quite as quickly as I might need it to. But it's a really cool piece of equipment, and it would be useful for some light hobby work and some circuit boards that aren't too high thermal mass. So yeah, pretty cool little device. Right, what was the next thing that I was going to do? Oh yeah, I was going to show you my surprise, wasn't I? I've got to find somewhere to put this now, it's not going to burn. There we go, that'll do. Just put this down. What other mains devices can we run off of this amp? Well, it's got... Please make the bench bigger so you can work on the US amps. Yeah, I will do, but the problem is I need like a good week and a half off of work so I can redo my workshop and make myself a bigger workbench. So, as you guys know, I haven't had any loud bass in my car for many years, which makes me kind of sad. I miss all the booming, I miss all the fun of having a loud car. So you guys will be pleased to know that I have made an investment. I have made an investment, and it's a pretty cool investment, if I do say so myself. Yeah, so basically, one of my customers, so basically, yeah, I had a customer come to me and he wanted me to supply some equipment to him for a van that he had, a Mercedes Vito van, and he purchased a whole load of digital designs, speakers, VO front-end speakers. He purchased some 3500 Series 15s, ESPs, an LW Audio 4.5K amplifier, and some tweeters and some other bits and pieces. And I got my good friend Henry from Hardwood Acoustics, the same guy that made my T-line door cards, to do the build for him. It cost him a lot of money, the equipment was quite a lot of money, and the van itself is very nice indeed as well. It's only been playing for a couple of months, and he had to sell the van due to some personal circumstances. And he offered it at a really cheap price. And he offered it at a price that I couldn't say no to. So I have actually purchased myself a fully finished DD audio, LW audio bass van, and it looks like this. So this is my new vehicle. This is a Mercedes Vito. It is a 2006 plate. It's what else am I going to say about it? It's an automatic diesel. It's done 34,000 miles, and it has had some modifications done to the engine. It's been chipped, and it has some intake changes and some exhaust changes. And it has, like I said, a fully fledged audio build inside. So I shall show you the audio build inside now. If I just change my pictures to show you what's inside. Yeah, so the quality that this will come through on the web will be very bad, so apologies for that. For some reason the pictures aren't loading properly. Okay, so yeah, as you can see, now annoyingly, the customer, he asked Henry to carpet the A-pillars. Now personally, I fucking hate the look of the carpet on the A-pillars. You see all this jazz up here, all this carpeted A-pillar? I think it looks terrible. So I'm going to get Henry to change that and make it all nice vinyl, just like in my T-line doors and my A-pillars. A nice black and cream vinyl maybe, or something like that. But yeah, it looks quite nice as it is anyway. You've got Digital Designs VO 6.5s and DDB3 tweeters on there. And then the seats are quite nice as well. If we turn around, we can have a look at the sixth order. So this is the seats, obviously, and this is the wall. So it's a walled vehicle. It's a sixth order, and this is the opening here is the high frequency port that you can see. Just behind the seats, there are 4 sealed cab Eminence 10-inch PA drivers, and these deal with mid-bass. So I get the kick mid-bass from just behind the seats, which are in sealed enclosures with lots of sound wadding inside. And then the bass is coming from the sixth order behind the seats, and the sixth order is tuned quite low. This system drops down to 20 Hertz very nicely, actually. It's a really good sound. That's another picture of the port exit with the Henry Hardwood Acoustics logo at the top. This is a little peek inside. So yeah, at the moment I'm only running DD 3500 series 15s with 700 series motors, so they're only baby subs at the moment. These will take about 1500 watts RMS, maybe to 2K each, and these are currently being run on a 4.5K Korean amplifier. So this is a better view of the sixth order. So you've got the bottom chamber there with the low frequency and the high frequency. Now this plays beautifully. The reason that there are screw holes either side of the port in the middle is because originally Henry made a port blocker, so to block off the middle port, which tuned the bottom chamber much better for low frequency 20 Hertz. But it turned out that we didn't need it. It actually dropped down to 20 Hertz with no port blocker at all, so that wasn't required. That's the Eminence 10s behind the wall, behind the seats. That's another picture of the seats and the wall. And this is the amplifier rack in the back. So down here we've got batteries behind the first panel. The second panel we've got the fuses and the bus bars. Then we've got the LW audio 4500.1, 1.4500. And we've got 3 Genesis profiles. We've got a single Profile 2. And then this is actually 2 Profile 4 Ultras stacked on top of each other. It looks like there's only one, but there's actually 2 that are stacked on top of each other, and that's doing the whole front stage. So you've got the Genesis Profile 2, I imagine, running the tweeters. I think that's how it's wired. And then you've got the Profile 4 Ultra running the DDVO 6.5s, and then the second Ultra running the Eminence 10s, and obviously the LW running the subs. there's actually quite a lot of space still in the back of the van that I can use as a van, which is really cool. The 6th Order doesn't take up a huge amount of space. It's still quite big in here. The floor does need a clean, so I'll sort that out. But yeah, it's very usable and it looks quite nice in here. It needs a clean on the outside, but yeah, that's basically my surprise. So there'll be lots, trust me, I'm going to be doing lots and lots of fun bass demo videos with this. So stay tuned to my channel if you want to see me doing some bass show-offs and demos and hair tricks with this. At the moment, it sounds like it's doing 152 decibels at 33 Hertz roughly. I'm going to take the SPL lab and measure what it's actually doing, but it sounds like about 152, 153. So that's pretty cool. Ha! Make a coffee using the amp. Could I make a... I could maybe make a coffee using the amp. I'd have to use an old voice coil. I could submerge a voice coil in like a bowl of water and use the amplifier to heat the water through the voice coil and make myself a voice coil Banda coffee. That would be really cool. Maybe. I would definitely recommend a decent soldering station. As I mentioned, I didn't have good results with the desolder. Great experiment all the same. Yeah, so the soldering iron that I have is pretty decent. It's an AOUA 2738A. So it's not the best, but it heats up very quickly and it has the heating elements in the tips themselves. So they heat up very fast. And yeah, it's very effective. It works really well for me. I get on very well with it and it's quick. But if it ever dies, I'll get something better, 130 watts or more. Sneaky Adam, can I come out and help with making a new workstation? Yeah, for sure, man. Fucking hell yeah. Of course you can. That'd be wicked. You realise I'm based in the UK, but yeah. Seth says, spend it on the truck. Yeah, man. Thank you very much, Seth. For sure, I will. I'm actually planning to put this Banda 10K in the truck in the Mercedes van. So I'm planning to put this in there, and I'm planning to build myself a new pair of 15s, which are going to be DC level 6 motors. And I've had Digital Designs custom build me some 8-layer coils. So those are like 6,000 watt RMS coils to go in those DC level 6 motors with the ESP baskets and carbon cones and whatnot. So those should be some pretty epic subwoofers. That's what will be going in the van. Yay, Matt's back on the live stream. It's been a long time since I saw Matt on the stream. Yeah, been doing very well, thank you, dude. Cheers for tuning in. You're just catching the end of this live stream. I'm pretty much done now. Done all the tests I wanted to do. Had some fun with the soldering iron and showed you guys the van. Sunfire, I don't know. I've never used them, but they look quite good. JCB make the best soldering tools, but you sure as hell pay for it. I'll check those out, man. That's a good tip. Thank you. 4-inch 8-layer coils. Yep, that's what I'm talking about. Fucking crazy. Jesus Christ. Sneaky Adam, I'm based in southeast London or in Kent. So yeah, if you're in that area, then for sure, man, we can meet up. So this 10K is about, yeah, so this is 10,000 watts RMS at 12 volts. So 14.4 volts is about 13K. So yeah, I'll be doing some videos of the van very shortly, because I know you guys are craving for some bass videos, so there'll be some really cool bass videos coming up with the van, and I've still got to have a think about what I want to do in the back of the van. So the back of the van is pretty much empty, as you saw in the picture. I've got lots of space in there to do some cool stuff, so I've just got to have a little think about what I want to put in there. Yeah, maybe a sofa, maybe a couch with a big flat screen TV or projector. Put some gamings in there, put some surround sound in there, you know, I don't know. We'll see. Maybe a sofa bed. Maybe I put a sofa bed in there so we can pull it out and, you know, go camping, go driving around the country, giving bass demos. Build a couch, which is the sub box. 5.1 home theatre in the back. Theatre recliners. Yeah, I got a few ideas. I actually, I've got a massive car show on the 24th of May. So if you guys have subscribed to my channel, you would have seen a video that I did last year called Modified Nationals with EXO. It hasn't had that many views. That video hasn't had a great amount of views, but it's a really fucking cool video. You get to see exactly what the bass scene is like in the UK. I get some really good bass demos from some really good systems, and you get to see what it's all about over here in the UK. So this year I'm obviously going to the show, but I'm going to be taking the Mercedes van, and I was thinking about putting some kind of setup in the back so that I can DJ from the back, because I am also a DJ. I've never showed any of that really on YouTube, but I DJ in my spare time, and also I do weddings and other corporate events and stuff like that. It would be really fun to be able to drop some mixes from the back of the van with the system hooked up. And I've also got my Digital Designs VO 15-inch PA speakers that I can make new boxes for that go on the back of the van or out the side doors or something, so that I can then play to an outdoor crowd, and obviously I can use the 6th order in the van for bass. So yeah. Bearage, read my earlier comment. You live in a good area. Wait. The comments are going pretty quick. Maybe I can save on room and board by sleeping in the back of the van. Nah, man. If you came round, you've got a room of your own. I've got two. What is it? I've got a fully fledged spare room at my place. Sometimes there's 2 spare rooms. His please, yeah, absolutely. The DC soft parts are no good. I have not had good experience with DC soft parts, so I'll be building my own using DD soft parts and building them by hand to ensure that the joints are very high quality and sturdy. Yeah, so Mitchell Roberts says you can make the entire back of the van into a 6th with 6 or 8 15s. So the reason that I don't want to change the build is, first, hinges and breaking the metal on the van and the doors and shit, because it's quite a nice conditioned van. So I don't really want to go down that route and basically end up with a van that I can't sell, that just disintegrates and I have to write off at the end of a couple of years. I want it to still be a daily van that I can drive, and I can still fit some stuff in the back, you know. So it'll be, yeah, you know, give it a year or two, and I might be interested in turning the 6th order into something bigger that can fit 4 15s maybe, or 2 18s, but I'm not going to go much bigger than that in the van. If I wanted to do a crazy loud build, then I would buy a piece of shit old banger, like some bullshit car that's rusting to pieces already, and I would just do a really ghetto, really fucking redneck, like, rat build in it. Like, I wouldn't bother carpeting anything, it would just be all MDF, and like the wires wouldn't necessarily be that neat, but it would be fucking loud, it would do the scores, it would set the records, and then I can just scrap it. No big deal. The 666 Bud, man, that's a very, very kind offer. Thank you very much. Thank you very much. Yeah, it's pretty much 3 AM here in the UK. I should probably go to bed now. Yeah, I think we're going to lock off the live stream now. So thank you very much to you guys for tuning in. And this experiment was interesting, albeit not the result that I was particularly thinking that we were going to see. But interesting nonetheless, and it means I can run this amplifier for the time being and see if it explodes or not. It's a little bit bigger. See, I want to drop this into the van, but you see the van, if I go back to Chrome, so it's got to fit well where this LW is. And this, obviously the Banda is quite a lot bigger than the LW, so I've just got to work out how that will fit in without changing too much of the build. I don't really want to change too much of this beauty plate either. So yeah, I'm going to look into that, see whether I can get the Banda in nicely and make it look nice as well, without changing too much of the build there. Yeah, so thank you very much guys once again for tuning in. Thank you so much to all you guys who sent any donations through on this live stream. I'm very flattered. This is crazy. I hope you enjoyed the stream, and I will catch you. I've got a lot of work to do over the next couple of weeks, so you'll probably see quite a few streams for myself doing some amp repair, and also some videos of the van as well, giving you some bass demos and showing you the upgrades going from the LW audio to the Banda. So thanks for tuning in, and I shall get some sleep and see you in the next stream. Bye.